Alrighty, buddy, welcome back. We are still working on part two, module two this week. There's only 4 assignments this week. They're all screenshots, they're labs from Net Academy. They will require a bit of brain power, but not too much. Again, we're still working with strings and they're different methods, and we're kind of getting into using them for different things. I'm going to try and keep this video short, but I wanted to walk through these assignments real quick. The first one, 2.416. Oh, that's not what I want to do. I want to go here. You are going to create a program that displays like an LED screen. You're going to take input from a user. The user is going to enter some digits, 1 through 9. And if they put a 1 in, you're going to print out the 1 as seen here. I think a lot of people get hung up in how to print that. So I'm going to try and make that easier for you. The 1, if you look at these numbers, they are in a grid of 3 by 5. So if we want to print them like they appear, we should have a multi-dimensional list with 3 elements, 5 elements, each containing 3 elements. I'll show you. So the 1 is easy. You've got 2 spaces and the hash mark, and that's the whole thing. Not the whole thing, but there's 5 of those, right? 1, 2, 3, 4, 5. Okay, so this, if I do this for I in range 5, print 1 I. So if I do this and run it, it throws up on me. Invalid syntax. Oh, I didn't put in for I in range. I get to going too fast. You can forget it. So you can see there, it printed out exactly what I had in there. So there's the 1. So all you have to do is figure out how to get these to print out when the user enters that digit. The 2, if you look at the pattern, it's got 3 across the first row. And then it looks like it's got 2 spaces and a hash. Then another 3. Then a 1 and 2 spaces. And then 3 again. So again, if I do 2 and print it, it prints a 2. So what I would do, and the hint here is using a list containing patterns of all 10 digits, 0 through 9, may be very helpful. So what you should probably do is then make a numbers or like a pattern list. And that's going to be equal to 1, 2, 3, etc. And then take in your user input and convert it. I don't want to give you too much because I know you guys are smart and you will figure this out. But yeah, that's how you do the patterns, and I think that's where most people get stuck. Once you got the patterns in the list, all you have to do is take in data, and if the user puts in 1, 2, 3, you print 1, 2, 3. Ta-da! That's easy enough. What's the next lab? 2, 5. Okay, this is the Caesar cipher, or improving the Caesar cipher. So if you've never heard of the Caesar cipher, this is when, I don't know, encryption began. You'll hear this in other computer classes if you haven't all heard it already. But apparently Julius Caesar would encrypt messages he would send to his troops or important people or whatnot, and that's where encryption began. It's sometimes referred to as Rot 13 or Rotation 13, and that means that instead of like A being the first digit, you would do, what's 13 digits after A? I don't know. N or something, but you would instead of an A, you'd write an N, and you'd encode the message that way. And the other person, when they get the message, they just convert it back so they can read it. It's super simple and rudimentary, so we're going to improve on it, sort of. The way we're going to improve on it is by making it so the user is going to enter a shift value. So you're going to have to take in user input in the form of a message and a shift value. So that's where this little handy dandy chart comes in handy. Again, I'll close it up on that. You've seen this before. So if you remember the ORD and character functions we went over a couple of weeks ago, the ORD function will give you the decimal value, and the character function will give you the character value. So you can switch back and forth between them, and that's an easy way to kind of do the cipher. So I don't want to give you too much here, but because you guys know how to take in user input. So take in the message, taking the shift value should be an integer. You're going to write a for statement for every character in the user input. If the character is a space, you want it to add the space as a space. If the character is a digit, you want it to add it as a digit. You want to concatenate your empty string with whatever digit or space that is. If it's an uppercase character or a lowercase character, you're going to have to do some weird stuff. So I'm going to explain 2 lines of code to you. So you got your for statement. And for every character in the user input, you're going to do something. If the character is a space, you're going to make it a space. Else if the character is a digit, you're just going to add the digit to the string. Else if the character is upper. So if the character is upper, you need to do some stuff. We're going to have, so let's say you have an empty string that's holding your encoded values as it goes. I'm going to call mine cipher. You're going to have the cipher plus all right, bear with me here. The character, you're going to have the ordinal value of the character. Let me just write this out, and then I'll kind of go over what it's doing. All right, so that looks a little weird. So I want to read from left to right, and this is why I kind of had to type it out. You want to read from left to right, but it actually does the things in the middle first. So we're going to get the ordinal variable, the ordinal, and again, we're coming back to this list. So if we're looking at an uppercase A, we're going to, if the user input is an uppercase A, we're going to get the ordinal value for that character, which is 65. And then we're going to add the shift value to 65. So let's say the shift is 2. We're going to add 2 to 65, which will make it a C. Then we're going to minus 65, find the modulus of 26 at minus 65. And this, so what this does, again, if we're looking at this list, there are only 26. So if your rotation or your shift value is 7, but they put in a Z, you're going to end up over here somewhere, uppercase, or lowercase a or b or whatever. We don't want that. We want it to wrap back around to the A, and this is how you do that. It took me forever to figure that out, and I'm not going to put you guys through it. So that's what you do if it's an uppercase, and then else if just else, because if it's a space, you're going to have if it's a space, else if it's a digit, else if it's a uppercase, and everything else can only be a lowercase. So there you go. The again, back to that back to that list. The uppercase letters start at 65. The lowercase letters start at 97. So this is what you do for lowercase, and this is what you do for uppercase. Then all you have to do as you're adding them to the list at the end, just print out your original message and the encoded message. And I know you can't see. Here you go. This is what your sample data should look like. They're going to want you to put it to put in lowercase letters, ABC, XYZ. They're testing that wraparound. They want to see uppercase characters, another XYZ, space, and 1, 2, 3. With a shift value of 2, you should get this output. This is going to require a little bit of brain power, but I'm pretty sure you guys are smart enough to figure it all out. Moving on. Let's see, 2517. Palindromes. These are fairly easy. If it's a palindrome is a word or a phrase that is the same forward as it is backwards. I'm trying to not to type everything out because some of you will just copy my code and then turn that in, and that annoys me. But if you take in a user phrase, you know how to take in input from a user. He's going to enter a text. He's going to enter a word or sentence, and you'll look at your test data. So in this one, it's a phrase with spaces, and it should say it's a palindrome. These both are. So it's not just a word. You're looking for a phrase. So you take in a phrase from the user, and if, what am I typing? If the length of that phrase is greater than 1 and phrase I'm converting it all up, or I guess you could do it to lower either. Now we've gone over these splits. We did list splits and I'm sorry. We did list splits and we did string splits. So this split right here, what's it saying is from the beginning to the end, stepping back 1. So we're looking for the phrase, and we have the phrase forward. That's the way it was typed in. So if the phrase forward, all matching uppercase letters, you could do lowercase letters, is equal to the phrase from the backwards. It's going to go from the first to last, but backwards, stepping backwards, and also convert it to upper. So if they are the same both ways, then it is a palindrome. Otherwise, it's not. That's pretty simple. Take in user text. You may want to get rid of all the spaces because the spaces won't be the same. See, like in the keep moving this thing. No, that's not right. The spaces are not the same. Like 10 animals I slam in a net. The 10 is one word, but then animals is a in mouths right here. So it's 3 different words. So you're going to have to remove all the spaces and then do this line. Compare it forwards and compare it backwards, and then you'll know if it's a palindrome or not. That's simple enough, I hope. If you have any questions, obviously, you can always reach out. And last one, we're skipping anagrams, and we're going to do the digit of life, man. There's a bunch more labs in here. I encourage you to do them all. I don't assign them all because I'm not a monster, but you should know how to do them. So it benefits you. Anyway, we're going to find the digit of life, and all this is taking in a number here, goodness gracious, you're taking in a birthday, which will be 4 digits for the year, 2 digits for the month, and another 2 digits for the day. Good Lord. And then you just add them all together, getting a number. But you're not adding them up to get, you need a single digit. So you're going to take in a birth date. Well, the length of that birth date is not 1. It's not 1. Good Lord. So this is going to continue and add them together until it is 1 digit. While it's not 1, it's going to continue to add them together. So your sum is, I'll start with 0 for n in number, sum plus equals the int of n. And we're going to convert that to a string and then print it. Super, super easy. Let's check our, oh, you're not even looking at what I'm doing here. Sorry. There it is for 2 seconds. That's all the code it takes. And then, oh, let me just do this. Pull my console up. So if we're looking at the test data, which you cannot see, the first one is, why is it not? Okay. 1999, 12, 29. Enter, and it is 6, and that works with the sample input. Let's try the next one. It's 2000, 0101. So we don't do birthdays like that. That's how the English do it. But that matches the test data, and we can do it the other way around. So if your birthday is December 29th, 1999, your number is still the same. It doesn't matter one way or the other. It all's going to add up to the same stuff, and that is your number of life. Anyway, that's the last one. If you have any questions, let me know. Thanks.